I am Dave Josephsen. I am the developer evangelist at Librato. I'm super excited to be here. I love you guys to death. Lisa is absolutely my home. I've been coming here for a very long time now. My first Lisa was in 2002. In 2004, I co-authored a paper that won the Best Paper Award, which is basically the pinnacle of my academic achievement. It's been all pretty much downhill from there. I also write the monitoring column in Login magazine that's unfortunately named iVoyeur. It was my idea, but after I had it, I was like, we probably shouldn't do that, but it stuck anyway, so apologies for the creepy title. I've also written several tech books, all of which have squiggly things on the cover, which is very exciting because actually this makes me the world's foremost authority on having written technical nonfiction books with squiggly things on the cover. So if you are considering publishing a technical nonfiction book that has a squiggly thing on the cover, I am available for consulting. You'll find my contact info there in the center of your screen. But I'm here today to tell you a story about how we ripped out a critical piece of our infrastructure at Librato and replaced it with something else without incurring any downtime and without our customers noticing through the magic of feature flagging. And I promise I'm not selling to you, but I need to tell you a little bit about who we are and what we're actually trying to run here, so you have the context. So Librato, if you're not familiar, is a monitoring software as a service company. We are built entirely on AWS. Our primary interface is a REST API to which you can emit metrics from any of the monitoring tools that you happen to be using. So basically the model is people who measure things wrap those measurements up in JSON. They throw them at our API. We catch those data points, persist them, and provide a suite of tools to help visualize and correlate and alert on them. We are a distributed team. I am part of a distributed workforce. We are headquartered on the West Coast, and we have various engineers sort of strewn about the countryside. And I actually have to apologize because this map is a rough approximation. When I went to make this slide, I realized I don't actually know where all of our employees live. Because I live in Texas, you see, where the US map is typically drawn to more accurately reflect certain socio-political realities. But my point is, we're a widely distributed team. And I'd like to tell you about one of my teammates in particular. This is Colin. He is one of my coworkers who lives with his cat in a land south of here, embedded in the yonder, named after St. Francis of Assisi. So not only is Colin sort of unfortunately situated outside of Texas, he is also a Java programmer, which makes him kind of an unfortunate guy in general, who is trapped in an undoubtedly strange and confusing land, which I think works in his favor as a protagonist. But the reason I want to tell you about him is because he just finished rewriting this huge piece of critical infrastructure which runs our CloudWatch integration. And I apologize in advance for how many times I'm about to say the word cloud in this presentation. If you were looking for a presentation to play the cloud drinking game and or run but the cloud, this would be definitely the one. So if you're an AWS user, you're probably familiar with CloudWatch. This is the Amazon service that collects and tracks metrics on your AWS instances. Our integration uses a read-only credential that is provided by you to pull metrics out of Amazon CloudWatch every so often, every few minutes, and then persist them in our metric system, which is objectively superior to CloudWatch in every way. And that might sound like bragging, but it's actually not a very high bar, which you know if you use CloudWatch. But anyway, we originally built this service about a year ago. We originally built it in Ruby, and we called the service CloudSnarf. We threw it initially on a few M1 extra large instances, which are sort of the Amazon general purpose instance with 7 gigs or so of RAM. But as our customer demand grew, the service expanded to upwards of 30 instances. And when we hit that bar, when we hit 30, CloudSnarf began to cost a little bit more than it made. Right, in money. So it was not pulling its own weight anymore, and it became clear that we were going to need to refactor it if it was going to be something that we could keep as a feature. The problem was the memory model. CloudSnarf would basically fork these worker rubies that would eat all of the available RAM. So And I mean all of the available RAM, to the extent that the kernel would actually get the killer involved, and then just all hell would break loose. The workload was already very bursty with respect to CPU, which you can see in the bottom CPU load graph there before the freakout. But visualized as like percent CPU, this is what the load actually looked like. So when the RAM was exhausted on one of these instances, it would basically just melt down, and we'd end up having to manually recycle it from the AWS interface. So not only was Cloud Snarf very expensive for us, it was also kind of wonky under very heavy load. This is more or less what Cloud Snarf's service dependency tree looks like. You have a set of worker nodes that are here in the center. They're all pretty much running the same service, but then they use ZooKeeper to perform a leader election, and whoever wins the election becomes a special kind of worker, basically like a queen bee. And the queen bee's job is to interact with Amazon via their various services APIs to pull out these metrics. So every so often a queen wakes up, batch queries Amazon, pulls all of these metrics down in an Amazon native format. And then the bee pushes each one of those metrics into a queue, which happens to be an SQS queue, where all of the other worker nodes who lost the election and are therefore just sort of normal worker drones wake up every so often, pop a metric off the queue, translate it into a Librato proper metric, and then push it into the same API that all of our other, well, excuse me, they use that MySQL database to, oh wow, that looks horrible. I apologize for that. It looks much better on my screen, you guys, if you want to gather around. It's kind of fuzzy up there. I don't know what's going on. But so yes, so once those workers have taken their AWS metric, translated it into a Librato metric, they post that result into the same API that all of our other metric data goes into. So ignoring the whole worker or leader election thing, which is just really, it's complicated to explain, but it's that the queen is really just a very simple JSON parser and fetcher. What we're doing here is we're spawning this worker that's going to pop a metric off a queue, translate it, and then push it into an API. And like I said initially, this worker was a full-blown Ruby process. And by process, I mean process, capital P. It has its own heap, has its own stack. And because outside of JRuby, there's no shared memory concurrency model, when we get a lot of metrics to translate, we wind up with a lot of processes. And those are very heavy, they take up a lot of memory, and they hose our instances. But hypothetically speaking, if we had some of these workers that were written in a different language, a language that had a stronger concurrency model, like Java, then these could be threads. And threads are a lot lighter, and they share memory, and they're more efficient in that regard. So with a JVM, we could probably run more workers per box here. And if we could do that, we could bring our AWS bill into the realm where Cloud Snarf made sense from a business perspective again. So I do have that dry mouth speaker thing, so I'm going to be rinsing occasionally, sorry. So this is Colin's mission. He needs to re-implement just the worker part of this process in Java. And that's not a problem for him. It's just the sort of thing that people who wear Basho t-shirts do all the time. The problem was the over 100 customers that were already using this service day to day and relying on it for their metrics. So if we reimagine this as a stream of data, a data flow from left to right, here is Colin's predicament. He basically needs to swap out the guts of this service here with a new threaded, probably initially buggy version of these workers without interrupting the already stable, pre-existing, if a little bit inefficient process. And when we imagine it like this, when we imagine it like a data flow from point A to point B, from point A to point B, sure, I'll go with that, B. We can also imagine that we could run both sets of these workers in parallel with each other. And then we could send a little bit of data to each of them, right? Each set of workers could use a different queue, and we could control the flow of data into each service, one or the other, by sending data into either one queue or the other, right? And so this was Colin's thinking initially, and what he did was he implemented what we call a feature flag in Cloud Snarf's leader code to choose between these two different queues. So this is a slightly atypical use of feature flags. If you aren't familiar with them, feature flags were originally created to enable experimental features for subsets of your users. So if you have a beta testing group, you can flag just the beta users to get the shiny new feature, while everyone else gets like the old ratty feature, right? And you can do this in a already running piece of code. They don't get a new piece of code, they get the same piece of code that the normal users are getting. But inside the code, we're choosing them to be flagged for a new feature, right? And it basically looks like this. Typically, you have an external, highly available system that sort of manages these flags for you. It keeps track of what subset of users belongs to what subset of features. And you query the flagging system from inside a conditional, inside the thing that you wrote. So it's literally like if flag is active, do shiny thing, else do normal thing. So for us, we use Rollout at Librato internally to manage our flags. And Rollout is a very nice system. It's a very light abstraction layer on top of a very simple data store. The upstream Rollout happens to use Redis. We use a fork of Rollout that we maintain that's backed by ZooKeeper instead. We don't have anything against Redis particularly, but ZooKeeper is already there. And like I said, it's not a very difficult data store to implement. So we query Rollout from within our source code. Rollout returns us a Boolean, which we can use in a conditional statement. And in this case, what we're doing is Colin modifies the leader node portion of CloudSnarf to check each inbound metric against Rollout to see if this metric is flagged for the new service or the old service, right? So the CloudSnarf leader basically just uses that answer to select between these two different work queues. One work queue for the original CloudSnarf workers and one for the new sort of Java-based workers, which we named Slingbot. So there's another piece of jargon you have to track. I wanted to show you, this is a very early changelog from GitHub, where Colin has added the feature flag conditional into the CloudSnarf program. And the reason I wanted to show it to you is because if you squint at it and you speak Ruby, you'll see that the initial change that he made was a little bit different from what I just described. And that's right here. Basically, Colin is saying, if CloudSnarf Slingbot feature is active for this user, go ahead and append the Slingbot queue to the list of queues. So in fact, what's happening here is that when the leader gets a metric, he emits the metric to both queues if the flag is on. And I wanted to sort of digress and point this out to you because I think it's a really powerful and nice example of what feature flagging brings to distributed systems engineering. We can literally tee off a subset of production data to mess with without ever sort of interrupting any kind of production service, right? So we control these flags, we control the membership of the flags, who's flagged for what, by interacting with chatbots in our chat thingy. I don't have a noun for that. So in this chat transcript, what you see is the first few moments of Slingbot's life and sort of the beginning of the end for CloudSnarf. In here, a very excited Colin has already added the flag to CloudSnarf and Rollout, and he's asking the chatbot the current state of the Slingbot flag. And you see the chatbot replies that the Slingbot feature is enabled for UID 43 in our staging environment. So day 0 was basically spent experimenting with a teed-off section of replicated production traffic. He was literally teeing off production data to an instantiation of Slingbot that was alive inside our staging environment only, which I think is super cool. I could stop there, right? Could I stop there? I mean, that's cool, right? But no, wait, there's more. Eventually, CloudSnarf obviously is changed to use either one queue or the other. And this transcript shows Colin enabling UID 1 in our production system. So at this point, we have live production data flowing into Slingbot, the new service for UID 1, which, as you can probably guess, UID 1 is our own sort of CloudWatch data because we are Amazon customers as well. So I need to digress again here to point out that internally CloudSnarf uses a series of event handlers for different data types that we get from Amazon. So if you're familiar with Amazon, you know there are like a myriad confusingly named group of three-letter acronyms for different services, SQS and ELB and EBS and all of this stuff. And so what we were trying to do here is we were basically trying to protect ourselves from Amazon adding new types of metrics upstream. So we made a series of handlers and then one that said, I don't know what this is, and tossed it out. And the idea was that if Amazon ever came along and added a new type, we would implement a handler for it instead of having to actually rewrite something substantial. But that pays off twice here because it lets us flag not only a specific user for Slingbot, but it also allows us to flag just that user's, for example, ELB metrics, because we can put the flag inside the handler for each specific type of metric. So Colin, as a programmer, was able to take a very procedural approach here. He didn't have to implement everything that CloudSnarf had at once. He could code one piece at a time, and piece by piece, once he felt good about the thing he was working on, he could flag it on, test it, and move to the next piece. And so you can see him here in chat, sort of over the course of the next few days, methodically bringing Slingbot feature complete, right? So it went in without even being able to do anything, and then piece by piece, it became feature complete with CloudSnarf as Colin created and then flagged on the data handlers as they became available. So here's a look at Slingbot's queue for the first few days. I said that each service is using a queue, so this is a look inside of the queue that we use for Slingbot. You can see here how many metrics the CloudSnarf leader is sending into the Slingbot queue. The vertical lines are annotations that show Colin's deploys. So these are the changes that Colin is making over time to either the Slingbot or CloudSnarf service, right? And as you can probably imagine, we were also keeping a very close eye on Slingbot's thread count. And these numbers initially were very promising. Right from the start, we were pretty convinced that we were going to be able to slash our instance count in half just from the efficiency that we were getting from using threads in the JVM rather than processes. That made the CEO happy, made Colin happy, improved Colin's cat's quality of life in quantifiable ways. So that was a sort of a happy period for them. So on the third day, Colin began experimenting with other users besides Librato. And you can see him here in this transcript, which reads from the bottom to the top, sort of flagging on employee accounts and phony accounts and accounts that are alpha user accounts that were basically created either for the purposes of testing or that were very, very experimental and had that agreement ahead of time. And mostly Colin is just vetting that there aren't any sharp edges with respect to UID handling here. We can see the pattern of his progress in this graph where he's kind of flipping on some traffic, he's finding a sharp edge, flipping it back off, deploying a fix, and then flipping it back on again. After a week or so of this, Slingbot is basically ready for bigger tests against production workloads. So up until now, we've been playing with individual users. But you may have noticed in some of the other screenshots that there's this percentage thing here. It's also possible for us to tell Rollout to enable a flag a given percentage of the time. We can literally say, Rollout, just answer yes 15% of the time to this flag. So what we're seeing here is Colin literally enabling Slingbot for 15% of our inbound production traffic. So if you can imagine, in effect, what feature flagging has given him is a knob that sort of controls the volume of inbound traffic flowing into Slingbot. When he turns the knob up, Rollout bleeds that traffic off of CloudSnarf and shoves it into Slingbot. And when he turns it back down, production traffic flows back into CloudSnarf. Super cool, right? Right. Glad you stayed. I think this is really cool. This is another chat log. It basically reads bottom to top again. I think it's very cool because in it we get to see sort of a day in the life of Colin as he's working on Slingbot. When he gets in the morning, down here at the bottom, you see him sort of checking the status of the flag. And then you see him over here sort of slowly turning up the knob on Slingbot until it's, from 15 to 30, until it's eventually up to 75% and running, at 75% load as he's sitting there sort of watching it, making sure everything's fine. He backs it off to around 25% around lunchtime, probably to grab a salad or whatever it is they eat in the yonder, and then, and then hikes it back up to 50% for the afternoon. At the end of the day, he drops it to 0 to unicycle home or hoverboard or whatever it is that the Java kids do in the yonder to reach their hibernation pods. And then eventually, he lets it run overnight at higher and higher volumes until we're basically just confident enough in Slingbot that we just never touch the knob again. And we can, at that point, delete it from our feature flagging system. So at that point, we basically successfully replaced Cloud Snarf workers with Slingbot workers sort of while we were live in production. The JVM basically shattered our expectations, bringing our instance count down from 30 to 6. So that was a 5-fold infrastructure decrease for this service. So go gadget, JVM. But Cloud Snarf is still with us. We're basically still running in hybrid mode since this Queen Bee is still a special purpose CloudWatch or Cloud Snarf user, excuse me. So the last thing Colin did was he added the leader feature into Slingbot, which, like I said, is not a very difficult thing to accomplish. It's really just a JSON fetcher parser. Initially, he ran both leaders in parallel, and he just threw all of the metrics, or allowed both services to throw all of the metrics into our API, and he just let the API sort out the duplicates. It didn't run for very long, so it didn't really matter in practice. And then he began sort of interspersing the timing so that the old leader would just sort of sleep for longer and longer periods of time. So eventually, the Cloud Snarf Queen process was just never brought up again. And today, Slingbot is processing on the order of tens of thousands of messages per second. Our 99th percentile latency is below 500 milliseconds. We run about 50 worker threads. We do get bursty sometimes. Our mean is about 2.5 gigs of RAM per host. And we are very comfortably over-provisioned at 6 C3 extra larges. And although Colin and his cat have not exactly lived happily ever after, the joys of feature flagging did strengthen their relationship immensely. So that's, I guess, a good ending. So yeah, I wanted to say thanks for having me, guys. I'm having a fantastic time at LISA, and I hope you are too. I hope you have enjoyed our time together. I think that I have left plenty of time for the awkward silence that will ensue after I stop talking. So questions, comments, points of clarification. Thanks. There it is, the silence I love so dearly.
Wanting to understand better this awkward moment where Colin has trialed out Slingbot against alpha users and test users, and now flows the first customer who really cares and wants their data through there, and he's looking for sharp edges. Surely at that moment, you dropped a few. Or what other extra handling did he have to add?
So luckily for us, we were also a customer of this service. This is a very good question. So no, in this particular instance, no, we didn't have to drop any of that data. We were sure beyond a shadow of a doubt that nothing was going to bite us when we started putting production load on this service, because it had already been running on our, production CloudWatch metrics for going on a week at that time.
So in fact, you plus your alpha users and so forth
Yeah.
was sufficient to weed out any data loss bugs.
Yeah, we are a very large customer of ourselves, but that is definitely, that's definitely why we have beta users for services that, that we don't run internally, and other shops that use feature flagging for services they provide. And you can, just like I sort of showed you, you can absolutely go to your beta users and turn it on for them. They feel special, they're getting a new thing. The expectation is that there will be some sharp edges in there. And then you can totally run, it's perfectly acceptable practice right now, distributed systems engineering, to run something like that at 2% production metrics for, a month, right?
So, I'll step back a bit. You mentioned that you run it for a while, and then when it's all good, you remove that from the feature flag system. And I just wanted to talk about that for a bit. Back in the day, I used to have my Perl code actually tweak the symbol table in Perl so that it didn't make the call to debug when debug was turned off, because the cost of the call and the cost of the if debug less than debug level was so expensive when you added it all up by tens of thousands of iterations. So my question is, per that, all that code doing all those tests, what do you see as the overhead associated with feature flags, and how do you manage that at scale?
That's a fantastic question. I'm not sure that I have a real great answer for it. I know that just sort of as an engineering team, because it's distributed system stuff, we're usually very focused on service latency. And as long as we're hitting our latency numbers, as long as this service hits its latency goal, we're going to be pretty much happy with, whatever overhead there is inside it. It's going to be acceptable overhead. We do a lot of, as you can imagine, instrumentation as well. So we do a lot of sort of internally measuring the size of this queue, or the count of these workers, or the time elapsed between this service and that service responding. And there's definitely an overhead associated with all that. But I think sort of, and I could probably come back and get you a better answer on exactly, I'm sure he's measured it, what the overhead is. That's a great question too. I don't know. I don't personally, but I'm sure the team probably does. Yeah, let me get back to you. Can you actually though really get back to me? Okay.
So kind of a tangent. When you have the ability with Rollout for somebody through a chat system to just sort of direct half of your traffic or some portion of your traffic to this experimental thing, what are you backing that with for some sort of eventual consistency that you want to enforce on how much of your traffic is going to this, or all of it's going to this? Like, how do you reconcile that developer fiddling with it with any sort of config management system?
That's a really, really big question. Let's see if I can back up just a few slides here. The short answer is, the way that we do continuous delivery requires a +1 from another engineer that's peered on the team. So you can see down here, you basically see Colin say, hey, I'm going to try to shift over the SQS metrics to Slingbot. This should be easy and shouldn't break anything. And what you'll see down here is another engineer come in and be like, yeah, I took a look and I'm +1ing it. So it's informal, but it works very well for us. Usually you see this in GitHub as well, where we use pull requests internally, and for a pull request to get merged, you'll have to have a +1 from another dev. There's a much bigger story around sort of how we move to production as a team, and how we track what's happening in production right now, and how we react to that stuff, which is a super interesting story, I think, but it's not something I could articulate probably here.
All right, everybody, thank you very much.
Cool.